I'm just going to talk to you quickly about work and energy. In physics we define work as a force times a distance. So when you actually apply a force to an object, you will find that it will move along at some distance, or it will move along a set distance according to how much force you've actually applied to it. Now that is called work. We measure work in joules, and the reason we measure it in joules is because when you actually do work to an object, you transfer energy to it. Force obviously has the units newtons, and distance will have the units as measured in meters. If you find this too complicated, we can put this into a triangle for you as well. So work, force and distance. Work is going to be simply force times distance, so you put work at the top of your triangle. We have force, and usually in physics we have distance is small d, like that. Now you're going to see now that when we actually do work, we actually transfer energy to an object. So let's say we have a box here, and this box has been lifted up. Okay, so this box has a vertical height or distance of 2 meters, and it has a mass of 10 kilograms. So the question could be, how much work is this box going to do if we actually drop it to the floor? Well, first of all, we need to work out what the force of the box falling will actually be. Now, the force of the box falling will simply be its mass times by the gravitational field strength, and the force of it falling is actually called, in this case, its weight. So its weight is simply going to be 10 kilograms, and I'm going to make it easy for myself and times it by 10 newtons per kilogram. Now in your actual exam they will specify what they want to use for the gravitational field strength. Now usually it's either 10 or 9.8. Sometimes they use 9.8 newtons per kilogram, but for simplicity, for me doing it in my head, I use 10. So the weight here is going to be simply 10 times 10, which is 100 newtons. So what work are we actually doing when we're dropping that box? So if we've dropped it from a height of 2 meters, the work it does is simply going to be 100 newtons is our force, and in this case it's a weight, because weight is obviously a force, and we're multiplying that by the distance it falls, which is our 2 meters over there. So 100 newtons times 2 meters gives us 200, and we can say Newton meters, because that's another thing you can use for work, or we can also say 200 joules. So when it falls, this box is actually doing work to the surroundings, and it's doing 200 joules worth of work. So that's the amount of energy that's actually being transferred. Now you may find that in certain circumstances where you drop it from a very high point, or there's a large height, so for instance a parachuter falling or an asteroid coming in from outer space, a lot of that work that the force is doing, the force of gravity, is actually transferred into what we call heat energy. Now this heat energy mainly comes from friction, and friction is basically slowing down the object. So for instance, if we had an asteroid, okay, and we'll have a very crude drawing for an asteroid actually falling down, there's obviously going to be lots of friction from the air particles, and there'll be a force resisting it. So we may have a force actually resisting it, which could be our drag, and we may have the force over here, alright, which is going to be the gravity component, or the force of gravity, which is causing it to fall in the first place. So this could be gravity. So that drag force actually slowing it down is causing work to be done, and that work is actually as a result of friction. Alright, and heat energy is being transferred. So that's something else. Now they may ask you in the exam to talk about brakes, car brakes. Obviously the car brakes are doing work on the brake discs of the car to actually slow it down. So that could be something else you will need to talk about. So let's do some questions on this. So if I swap to an exam style question, let me just get my red pen. So it says here, the diagram below shows a small meteor entering the Earth's atmosphere at very high speed. And it says these questions are about energy transferred when work is done on an object. So exactly what we've just been talking about. What two forces labelled A and B in the diagram are acting on the meteor? Well, first one, obviously we have gravity. Okay. Now they will probably accept if you said weight, okay, as well, as weight is obviously a force. So either one of those they tend to accept. Now the one that's acting against it in the opposite direction is known as drag or air resistance. Either one is sufficient. So then it says force A is much larger than force B. As you can see here, this is what we call a vector arrow, by the arrow for A is actually larger than B. So that's how you tell the force is bigger. Pretty straightforward, but these are actually very, very powerful tools that you use in a lot of different diagrams. It says, how does the kinetic energy of the meteor change in this situation? Well, because there is a force being applied in the opposite direction, so force in the opposite direction, we know that that is actually going to slow it down. Alright, so obviously if you apply a force in a direction opposite to movement, it's going to reduce its speed, so it's going to cause it to decelerate. Because it is decelerating, therefore, the kinetic energy is actually reduced, because kinetic energy is only present when an object is moving. Alright, and it's related to the velocity of the object. So obviously if it's slowing down, the kinetic energy is going to reduce. So I'll say kinetic energy is going to decrease, let's say. Then it says, how much work is done by force B over a vertical fall of 200 meters if the force is 13 newtons? Well, simply we know work done. So the first step I always do in these things is to write down my equation before I work it out. Work done, or work, is force times distance, and then I do what's called plug and chug and just chuck the numbers in. So work is force, which is 13 newtons, it says in our question. 13 times 2,000 meters. Alright, and I can put newtons there as well. And I know work is measured in joules. Let's see, 13 times 2 is 26, and I add on 1, 2, 3 zeros. 1, 2, 3. So the answer there is 26,000 joules. Another question here, it says the diagram below shows two identical balls on top of a ramp 2 meters above the ground. So here's our ramp, here's our balls 2 meters above the ground. It says these questions are about the work equation, so we've obviously put that earlier. It says the ball on the right side falls vertically. Calculate the work done by its weight if it weighs 17 newtons. So again, I'll start by writing my equation out, because that's always what you do. Work is force multiplied by distance So my force in this case is 17 newtons, and sometimes when you're reading through the question it might be helpful to highlight the key information you're given. So the key information for us is that 17 and that 2. So 17 times 2 meters, and if I'm not mistaken, double 17 is 34, and that will be in joules. Okay, so you can write J or joules, however you wish, and we get the marks for that. Then it says the ball on the left side slides down along, it slides along the slope or down the slope. Calculate the work done by its weight as it rolls down the ramp and reaches the floor. Well, actually, something interesting with this question is that the work it does is the same, and the reason why is because the vertical distance, so the distance from the top here to the floor, is still 2 meters. So it's still actually doing 2 meters worth of work. It's only 2 meters above the ground. Regardless of how far it actually slides down here, the energy transferred is going to be to do with its vertical height. Nothing to do with the distance it actually slides along that way, because gravity, as you know, acts down. So therefore the work is actually in the vertical direction. Therefore, work is force times distance again, so we have 17 newtons, because it will still require the same amount of force. Obviously its weight's the same. 17 newtons times distance, which is 2 meters, and once again no change, 34 joules.